In this example, we will be matching a rational function with its graph. We cannot just pick a letter, we actually have to justify our choice. So to start with, we will find the vertical and horizontal asymptotes of this function. Vertical asymptotes happen when the denominator is 0, so just take the denominator and set it equal to 0. Solve for x squared equals 16. Take the square root of both sides. Square root and square cancel each other out. This is x equals plus or minus 4. So there are two vertical asymptotes, one at x equals -4 and one at x equals +4. Now let's go ahead and look at the horizontal asymptotes. Horizontal asymptote depends on the degree of the numerator and the degree of the denominator. The degree of the numerator in our function is 1. The degree of the denominator is 2. So this is the case where the degree of the top is less than the degree of the bottom. So the horizontal asymptote is at y equals 0 or x-axis. Okay, we can narrow down our graphs at this point, so let's go ahead and look at them. So graph A does not have a horizontal asymptote at the x-axis, so it's not graph A. I'll go ahead and cross it out. Graph B has a vertical asymptote at -4 and another one at 4. It also has the horizontal asymptote at at the x-axis, so this one still works. Graph C has one vertical asymptote at -4, but the second one is at 2, so it's not going to work. Graph D fits our criteria. Graph E also does not have a second vertical asymptote at 4, and graph F has the horizontal asymptote not at 0 and the vertical asymptote not at 4, so definitely does not work. So we're down to B and D. We need to figure out which one it is between those two. The easiest way to do that is to create a test point. And the easiest test point is the y-intercept, so when x is 0. So y would be 3 times 0 plus 6 divided by 0 squared minus 16. So this is 6 over -16. I know it's a super small number, so we can't really know whether our y-intercept is at that spot specifically, but a lot of the times we can come pretty close. So this has to be in the negative, and it's less than 1. You could reduce this fraction if you wanted to by 2. This is 3 over 8. Now let's look at graph B. This looks very promising. It's negative, and it is definitely less than 1. But we have to look at graph D to compare them, because if they are very close to the same spot, we would have to pick a different test point. Graph D, though, has the y-intercept also in the negative, but it's bigger than 1, so it's not going to work for us. So it's not graph D, it is graph B for this function. Let's try it again. And we will start with vertical asymptotes. Take the denominator, x squared plus 2x minus 8 equals 0. X. So two numbers that multiply to -8 and add to 2. That would be 4 and 2, and we'll need 4 to be positive and 2 to be negative. So x equals 2, x equals -4. So the vertical asymptotes are at -4 and 2. And horizontal asymptote, degree on the top is still 1, degree on the bottom is 2. So it's the same case where the degree on the top is smaller than the degree on the bottom. So it is at the x-axis or at the line y equals 0. Let's go ahead and narrow down our possibilities. So the first graph A, it has asymptote, the vertical asymptote at -2 and at 4, but we need it to be at +2 and -4, so it does not work. Graph B has the correct vertical and horizontal asymptotes. Graph C, the signs are reversed on the vertical asymptotes. Graph D, the horizontal asymptote is at 2, so it's not going to work. Graph E, also reversed signs on the vertical asymptotes, so we're down to 2 graphs, just B and F. Let's go ahead and create a test point to make sure that we can pick between those. You can pick any x value that's on your grid, but the easiest one to test is x equals 0. So when x is 0, y equals 3 times 0 plus 6 divided by 0 squared plus 2 times 0 minus 8. So this is 6 over negative 8. If we reduce it by 2, this is negative 3 over 4. So again, it has to be in the negative direction and fairly close to negative 1. So if you look at graph B, the y-intercept is positive, so graph B will not work. Let's make sure that graph F works, and it does negative and very close to negative 1. So it is graph F for this function.